We can use differentiation to verify if a function is a solution to a differential equation. And this is best illustrated with an example. So here we have q of t as a function of time, and every other term is constant. So on the left hand side, we take the derivative. So this term drops out because it's constant. And differentiating the exponential term, we obtain the following expression. Now on the right hand side of the equation, we substitute for q, which gives the following expression. And now we can cancel out these terms, and therefore this expression becomes positive because the negatives cancel. And therefore these expressions are equal, which means that q of t is actually a solution to this differential equation. Let's verify that x is a solution to the following ordinary differential equation. So if we differentiate x with respect to time, and noting these are constants, well, we get omega by a cosine omega t plus phi. And then differentiating this again, we get the second derivative of x with respect to time is equal to minus omega squared a by sine omega t plus phi. And what you do is substitute with the second derivative and x into this ordinary differential equation. And you'll see that the left hand side is equal to the right hand side. So therefore x is a solution to this ordinary differential equation.